Okay, before I continue with a new chapter, let me just go through the relational calculus quickly. There are some sections that I didn't cover because you already know them in ICS 253, like this one here, okay? Like this, which is slide number 17, and slide number, let's say 20, slide number 21, and so on. So don't worry about them, okay? So I'm not going to ask you whatever you have done in ICS 253, so you don't need them. So all you need is just look at the examples I gave you, which are these examples, just understand them. So expect similar kind of questions in the quiz, yani, okay? Most probably with relational calculus, we'll just give you a quiz and forget about it. Yani. I think that's what we will do. So, okay, so that's all about what I want to say about relational calculus. Okay, so all of this detail is here, and it is you don't need it. Just go directly to the examples I showed you and just understand them. Okay, that's all I have to say about relational calculus. So now let's start a new chapter today. It's called normalization. Okay, and functional dependency. What does it mean exactly? This chapter, what it's telling you is when you confront, okay, when you see a bad design, how do you convert it into a good design without looking at the requirements? Okay, for example, you went to a company and they showed you their logical design. Okay, how do you convert this logical design from a bad logical design into a good logical design? So we are talking about in the logical design level only. Are you with me? Okay, so yes. This chapter, it's telling you the following. This chapter, given a bad logical design, how do you convert it into a good logical design without going back into the conceptual design or the what? Or the relational design, or so the requirements, I mean, okay? So simply, this is what I'm telling you. Let me just repeat what I said again. You are given this only. You are not given requirements, and you are not given what? The conceptual design. They showed you only this, and they tell you this is a very bad design. Can you convert it to a good design for us? Yes. So take this L and convert it from a bad L into a good L. So this is what we are going to read in this chapter. Okay, so this is the objective of this chapter. And don't be surprised when you go to work in companies, you will find a lot of bad logical designs. And they might ask you to convert them to a good logical design. So let me show you an example of what you gave me the first day you came here. Okay, you know the library database? Some people did that. Some people, I don't know whether you still remember the library database. Let me just assume you do. That was your first homework, is it? Did I give you homework in the library database?
Yes.
Yes, I did. Yes.
Yeah.
Exactly. So let's assume that I want to create a database of the small library that I told you about in the first day you came to my class. Some of you did it this way. You wrote big book ID, the title of the book, and the number of pages in the book, and the member who borrowed the book, member ID, and then member name, and the date of birth of the member, okay, and so on. Some of you gave me in such a way. Did you see this design, Shabab? This is a logical design, right? This is a logical design, isn't it?
Yes, absolutely.
Now, what do you think about the design? It's a good design or a bad design?
Not good.
Let's take some data just to show you how bad this one is. Eh? Let's take the first book. Let's say book ID is 1, okay? And the title is what? Java. There's also ISBN, so I have left some of the columns out. Let me just put ISBN also just to insert. Let's say ISBN. Number of the book is, let's say it's like 111. It doesn't matter. The book is Java. Let's say it has 400 pages. Who's the member who borrowed it? Let me say he's member number 1, Member name is, let's say he is Salah. Let's say his date of birth, and let's say it is so and so on. Okay.
No, it's bad design. We should have two tables, a member and a book.
Excellent, excellent. That's what I want to come to, Sahib. Now, for example, I have the same person, another person called Salah, also borrowed book number 2. So book number 2, ISBN, let's say it's 222. Let's say it is Python, whatever it is. And then let's say it has 500 pages, my wallah. And the same guy, member ID number 1, the same Salah, and the same date of birth. Okay. Do you see any problem here, Shabab?
Yeah, we see it. And
now,
I think there is other problem. I think
there are many problems here. The first
Yeah.
problem is redundancies. Why do I repeat Salah date of birth? Which each time Salah, let's say if Salah borrows 10 books, I have to repeat Salah 10 times and have to repeat his birthday also 10 times. Right? So this is what do we call this one, Shabab?
Redundancy.
Redundancy. So this is very bad. So we don't like redundancy. Salah has to be written only in one row, in one table. That's it. We should not repeat it again. But here Salah will be repeated each time Salah borrows a book. You understand? His date of birth also will be repeated each time he what? He does that. Now, what about if book number 1 is borrowed by another person? Book number 1, which is the same ISBN number. This is redundancy verb here, Shabab. Title is what? Java. Pages is what? 400. He was borrowed by member number 2 this time. Let's say his name is Sami and his birthday is so and so. Again, each time somebody borrows book number 1, I have the same book ISBN number I have to repeat. I have to repeat the title again. So many redundancies. I have to repeat the page again and so on and so on. So you can see there is a lot of redundancy here. So this is a very bad what? It's a very bad design. You agree with me? It creates a lot of problems if you design it this way. So what do you think the solution is?
To create 3 tables.
So this, to break this table into how many tables? Break this table into how many tables?
Into 3. 1 book, 1 member, and 1 record, for example.
Exactly, 1 record. In fact, we should have not 1 table, but you should have 3 tables. 1 table should only contain the books, no borrowing details whatsoever. The other table should be purely what? Purely members, isn't it? Only members. I should not mention any book there, just members. The third one will come, what? Will make what? Will make members, the borrowing. Yeah, so we'll take the ID of a member with the ID, we'll match with the ID of the one who borrowed. So, in fact, we should have 3 tables. You agree with me, Ashab, or not?
Yes.
Some of you did design it this way the first day because you didn't know what a good design is at that time. So you will go, in fact, a lot of companies and you will find this kind of a design, Shabab. Don't be surprised. So automatically what you should do is you should take this bad design and convert it into a good design by breaking this one big table into a number of small tables. Are you with me, Shabab? And I will show you how to do that. But before I do that one, this is redundancy, and we hate redundancy. Redundancy, when you see redundancy, automatically you should know this is a bad design. Do you understand what redundancy is, in case you forgot? Well, is that clear for you, Shabab?
Yes, it's clear.
Very good. Another student, when I asked you the first day, he did it this way for me. He was smart. He removed the borrowing and the members from this table totally. He said, no, we should not put them here. They should be in separate tables. But he did another mistake. He put the author here. He put the author here. So, so he will have only the books. He will not have, so book number 1. So this is going to be the primary key. So he did that. And then what he did was he wrote the author here. Authors. And what did he do? For example, this book was written by 2 people, Sami, Ali. What about this book? This book was written by 5 people, let's say Mr. A, Mr. B, Mr. C, Mr. D, Mr. A, just save time, معلش. Do you see a problem here? Sorry. Do you see a problem here? What's the problem here?
Multi-value
cell.
Exactly. We don't like many values in a cell. Like this is good. One cell, one value. One cell, one value. One cell, one value. One cell, one value. But here, one cell, two values, two authors. One cell, five values, five authors. And we didn't like that one. So the second thing is when you go to work for a company and when you see multi-value attribute like this, automatically know this database was created by a person who doesn't know database. Okay? So what do we do, ya shabab, when we have this kind of a problem? What do we do? How many tables do we create?
Make an author table.
You make an author table, then another table which will link the author with what? With the book, صحيح?
Yes.
So we need three tables. Yeah. Some people, they were smart. They said, oh, let's do this. I think they knew that multi-value is bad. When I told them multi-value is bad, so they changed their mind. They said, okay, let's do the following. Author number 1 here. Author number 2 here. Author number 3 here. Number 4 here. So he said, which of the books has the most authors? Let's assume the book which has 5 authors. In fact, I have seen some books with 18 authors, okay? But let me just say that. Yeah. Now, tell me. So this author number 1 was Sami, and author number 2 was Ali. For this one, author number 1 was A, author number 2 was B, author number 3 was C, number D, and E. These are names, just put them ABC just to make it simple. Do you see any problem here?
There is nulls in the first.
Many nulls here. So this book was written by 2, so the other 3 will be nulls. A book which was written by 1, for example, this book was written by only 1 person, let's say. Okay. Pages. It was only written by 1 person. His name is, let's say, Sami, whatever it is. That's it. He's only 1 person. So what do we have here?
Null. 4 nulls.
Null. Yes, 4 nulls. You are right. This is also a bad design. We don't like a lot of nulls. So when you go to a database, when you see a lot of nulls, automatically understand this database design is not a good design. So somehow we have to change it. But to change it, you don't have to go back into the conceptual design, or you don't have to go back to the requirements. You don't even have to do that. You can directly do it from here. But how do I do it? Okay, you have to do it first of all. I'm going to break this into many tables, and then so on. I will show you, inshallah, how to do that one. But let me go back into the previous table again, the one I showed you in the beginning. Okay, for example, I showed you this table, and I said this is a bad design. Why? Because you are mixing the book, the member information, and the borrowing information in one table. Don't do that. Don't do that. Sahih? What we should do is we should really separate the books by themselves, the members by themselves, and the borrowing by what? By themselves in a different table here. So in fact, this is what I have to do, Shabab. Okay, so to do that, this is what I am going to teach you today. I'm going to give you a bad design, then I will show you how to convert it into a good design. So this is what we are going to do. So this is the topic of this chapter. So it's called normalization. So this process of converting a bad design into a good design, it's called normalization. So I'm going to show you normalization, how to do normalization, how to normalize. But to do normalization, first of all, you have to understand what functional dependency. What does functional dependency means? Functional dependency simply means, okay, when I'm going to take this bad design and break it into what? Into a good design, I have to make a number of tables. I'm going to break it into many tables. Which column will go with which? For example, here, which one will go with which? You said I will have 3 tables, right? So which column will go to the, so what are my 3 tables? One is going to be called a book table. One is going to be a member table, and the third one is called the record, which is a borrowing table, right?
Yeah.
Tell me, which one of these columns will go into the book table? Which one?
The book ID,
ISBN.
ISBN.
Exactly. This one and this one and this one and this one. I think this, let me put them yellow. These columns will go to a different table, what we call what? The book table, isn't it?
Right.
How do we know that?
Experience.
You are right. But sometimes they can be complicated. This is easy. So I'm going to show you something called functional dependency. You tell functional dependency, Hada. This functional dependency will show you which column should go to which table, okay? So I will show you this technique, which we call functional dependency. This will show you which column should go into which table, which columns should go together. So I will teach you that, inshallah, also in this chapter. Now, what about these three? Member ID, member name, and date of what? Of birth. This three should go into what? Into a separate table, sahih? Let me just put them like this table. So this will be one table and this will be one table. And the third table, it should what? It should combine what? It should combine the book ID with what? With the member ID. But we didn't write the date of borrowing, isn't it? So this is the date of what? Date of borrowing. Start date. Start date. And what? Return date, sahih? Or send date. I'm talking about the borrowing date. Now, tell me, the borrowing should have what? Which table is, which column should go to the borrowing, ya shabab? In the borrowing, I should have what? I should have the member ID. I should have also what?
Book ID also.
The book ID plus these two, sahih wallah?
Yes.
So these two will go to a different table. So this will be one table. Also, this will be what? This will be a mixture of what? Of this and that. This also will be a mixture of this and that. This will go to this will go to both tables, and I don't know how to color them. Okay, so this is how you should do them. You should understand something called functional dependency. Okay, so let me just go through the slides quickly. So basics of functional dependency. So functional dependency, inshallah, which I have not talked about up to now, will show you which column should go to which table. Okay, for example, here I showed you there are so many columns. How do you know this will go to the book table, this will go to the member table, and this will go to the borrowing table? We do that one by a technique called functional dependency. If it is easy like this, you don't need functional dependency. Automatically you can do it. But if it's complicated, then you need functional dependency. So this is chapter 14, and only required chapter sections 1, 2, 3, and 4 only. Okay, you don't need the other sections. So informal design guidelines. So what he is telling you is we are doing everything at the logical level. So forget about the physical level. Yani. So of course they will be affected. Yani. If the logical level is affected, the physical level will be affected. Now I will come to this one later on. I'm not going to explain this one now. Okay. Now, 4 informal guidelines to measure the quality of relational schema. How do we measure the quality of goodness of your database design? How do you know it's a good database design or a bad database design? These are the 4 guidelines. First of all, the guideline number 1, semantics of relational attributes. What it means is simply, here, the attributes should really belong to one entity. They should not have a mixture of what? Of many entities. For example, here I have 3 different entities. I have the book entity, I have the borrowing entity, and I also have the member entity. So in one row, I am getting 3 different entities. So the semantics of the columns is not clear here because it's a mixture of many entities. So when you have something like this one, we don't like it. Okay. So simply what it means is mixing many columns of different entities in the same row, it's not a good idea. Reduces redundancy. I think you have seen this one, Sahih. So when we have less redundancy, it's the best. In fact, we like no redundancy if it's possible. Sometimes you cannot avoid it, and I will tell you when we cannot avoid it. Also reduce nulls. We should not have a lot of nulls. And I showed you, if you make outer 1 and outer 2 and outer 3, some of the columns will be null. So we don't like a lot of nulls. Now, disallowing generating sparse tuples. Now, I'm going to talk about this one, inshallah, by example. So forget about guideline number 4. Okay, simply what it's telling you, when you are going to perform join, if your design is bad, you will get a lot of wrong rows. This is what he's telling you. So this is particularly when we do the join. So when I have two bad tables, and when I join these two bad tables, the output will be also a bad table. This is what he's telling you. And I will show you an example, inshallah, بعد شوية. So these are the guidelines. So you should not have what? Semantically. So the attributes must be semantically for a particular entity. We should not have redundancy. We should not have null values. And we should not have sparrow staples. Okay, so if you don't have this, your design is particularly, most probably it will be good. Sorry. Let me take you now to a design. Look at this design, Shabab. This is a good design. This is employee table. This is department table. This is project table. This is workers on table. And this is the department locations table. ما عندنا dependency هنا ما مشكلة. Okay, we don't care about the dependence in this database. As you can see here, this is a good design. Employee, every column here belongs to employee. E-name is for the employee. SSN is for the employee. Birth date, address is employee. Department number is all for the employee, which department he is. Department number, department name, department manager, SSN, and so on. So this is a good design. Do you agree with me, Wallah, Shabab? This is a good design. This is a bad design. Look at this. So he took all these 5 tables. So he created out of them, he just converts them into 2 tables. Suppose he went to a company and he found that they have only 2 tables in their database. And they have a lot of problems. And they tell you to fix it. Fix it معناته ايش? Take them from this bad design into what? Into this what? Good design. معايا ولا شباب? So how do I go from such a bad design into such a good design? The first thing, look at this design يا شباب. Do you see هنا problem يا شباب? Can you tell me in the first table?
Yeah, he mixed the department information.
Yes.
With the employee information.
Information, exactly. So he took 2 tables and he put them in the same table. So this will create a lot of redundancy. Can you tell me what kind of redundancy you will have here?
Yeah, there is the D number
and D
multiple
name.
times. Yeah,
D
number
name and D messenger.
Yeah.
So these 3 will be, for example, let's take a person, let's take 10 employees who work in department number 1. And the name of the department is called research, 10 people. So let's say his ID is number 1. I will put his name is, for example, Mr. Salah. His SSN equals to number 1. His birthday is so-and-so. His address is so-and-so. His department number is the department number 1. His department name is research. His manager is the guy whose ID is 22. So for each person who works in the same department, I have to repeat department number 1, department number name, research, and 22. So this department name, which is research will be repeated 10 times. Department manager, which is 22, that SSN of the manager will also be repeated 10 times. So I am getting redundancy here, which is a very bad design. So this, in fact, should be divided into 2 tables. What about this one?
I believe it has the same issue as the first one. There is a redundancy also.
Yes. In fact, this one is, I don't know how many tables this one is. I think this is also 2 tables. It's 2 tables. He put them in 1 table. You're right. The red ones should go to 1 table, and the blue ones should go to a different table. Isn't it?
Yeah. Right.
Yes. So it should be 2 tables. Now I have a third table here. Third table. Okay. One for department location. It's okay for that one. Okay, fine. The reason is I removed the department location من هنا مش موجودة عشان كده. Okay. We have this location, but this is not the department location. This is a project location, which is different. Okay. So this one is location is for what? For the project. What is the project? Yes. So the project location. It's not multi-value, but this one is multi-value. عشان كده عملناها table الحالة. Anyhow, so now you know what is the motivation behind this chapter. Don't be surprised when you go to work in companies, you will find this kind of a bad design. Okay, you will find such bad design. So they will ask you, what shall I do? In fact, I have seen some of my students who went for co-op. And then they went to a company and they found so many bad designs, and they really helped them to convert it to a good design. Even co-op students, they have done that. Yeah. Anyhow, so let's go now into a bad design problems. In a bad design problem, first of all, I have to storage wastage. Why? Because we have a lot of redundancy. Why do we have to have redundancy? It's a wastage of storage. Do you agree with me, ولا لا يا شباب? Okay, it is a problem. Will I get? I will tell you why. For example, let me go to this one, to this هنا. I bought a new book. قبل كده ما أظهرش الكتاب يعني في المكتبة حقتي. I just bought it now and I want to put it in my what? In my library. But nobody has borrowed the book yet. Tell me, what shall I do here?
There is an issue because there will be nulls.
Exactly, because nobody has borrowed the book yet. Let's say I bought, it's a book number 3. It's a new book, صحيح? Let's say this book is, his ID is, his SPN is 333. The title of this book is C++, for example. And it has 800 pages. But nobody has borrowed it yet. So what do you think will happen to this? Null, 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 and null. So it creates also a lot of nulls when you insert. We call this one insert anomaly. We call this one what? Insert anomaly. What is it? We call this one insert anomaly. So when you insert, you will get some problems. Sometimes you will create a lot of nulls. Are you with me? Now, you will have another problems. What is the primary key here, Shabab? What's the primary key here?
We have multiple.
Yeah, multiple primary keys, right? Even this one is a big problem. Yani. I have to make my primary key book ID and what? What's the problem if I make my primary key is a book ID and what? And member ID, صحيح? If I do that, my primary key, so I will make this one my primary key together with this one. It's one primary key. Did you see a problem here, Shabab, if I do that?
Yes.
What's the problem?
If the same person borrowed the same book again.
He cannot, صحيح? Yeah, right.
Yes.
According to this database, I cannot borrow the same book twice. Because my primary key will be what? Will be violated, say. For example, I cannot borrow me Salah book number 1 again. I cannot do that one. Let's say if I write book number 1, which is Java, I want to borrow it. What's my ID? My ID is 1, say. So this is 1, this is 1, which is the same as this is 1 and this is 1. So there is what? The primary key became duplicate, which is not acceptable. So you will have a lot of problems when you insert. Maybe you will have a lot of violations in the primary key. Then what you have to do, you will be forced to include this one as your primary key also. Isn't it? So you will say the book ID and the member ID and the start dates, the 3 of them together has to be my primary key. So this will have one primary key out of 3 columns. يعني. It's a mess. The circuit design is a mess design. يعني. فهمت علي؟ طبعا هنا you should not borrow the same book twice. ما ترجعوش وبعدين تاخذوا ثاني مره بعد شويه. لا مش مسموح لك. Because the start date is different. And so on. يعني. So because of that, so you will have a problems when you insert if your design is bad. What about, can I have a problems when I want to delete a shabab? Let me show you another database, معلش. Let me show you another database here, which I have here. طبعا this is a bad design. I'm really putting the department, the employee and the department table مع بعض. So I have Salah SSN is 111, his birthday is this, and he's from Khubar. His department number is 5, which is research, which is 22. كل ما قلنا 5 research 22, 5 research 22, 5 research 22. So this is redundant data. You agree with me ولا لا يا شباب?
Yes.
I agree.
It's a bad design, say.
Yes.
So here, if what is my primary key? My primary key is SSN. شايفينه? It's SSN. So the problem with this one is every person what? Okay, so you are putting what? SSN, no problem. Now, what about if I want to insert a new department number, let's say 7? What shall I do? Can I insert it?
You can't.
I cannot. Why not?
You have
Yes.
to have an employee.
Yes, that works in it.
Exactly, because the primary key is SSN and the primary key cannot be null. So I want to put a new department. So let's say department number 6. I will put 6. Department is ICS. And the department manager, I will put the department manager. But up to now, let's say I don't have any employees. Okay? Now what happens here? So this will stay, will remain what? Will remain null, 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 null. But the primary key cannot be null. So what shall we do, Shabab? We should really have what? We have to just put this new department in a paper and wait until an employee comes and becomes in that department. Otherwise, we cannot put it. Isn't it? So because of the stupid database design, we cannot really insert that information. But لو كنا عملناها 2 tables, I could still put it in the department table without no employee. That would be easy. But here, you are putting the employee and the department, both of them in the same table. So I cannot really have a department unless I have an employee. Let me show you this one. So it means I cannot insert this new department called accounting without what? Without an employee. So this all yellow ones will be null. Because SSN is my primary key, this will not be allowed by the DBMS. The DBMS will not allow me to insert this one. So I cannot insert this one anyway. So I will have insert problems. Anomalies معناته ايش؟ يعني problems. You can call it like insert problems. Okay. Also, if I want to insert a new department, a new employee without a department, شوف, I can insert him here. That is no problem because the SSN is a primary key. But I don't have a department, so I will make the department null and null and null. So many nulls. So the insert will create a lot of nulls, or the insert will be forbidden because your design is bad. Let me show you another problems with delete. See this delete problem. Do you see a problem with delete, Harry? I want to delete Badr. I don't like him anymore. I want to fire him from my department. From my, he's not an employee anymore. But what happens?
Then I will delete a new department. A whole
exactly.
department.
The problem with Badr, he's the only one in his department, صحيح?
صح.
Yes.
So if I delete Badr, I am also losing information about the department, which I don't want to do. صحيح? So by deleting Badr, you are also deleting the whole row. Delete means delete the whole row. معي ولا إيه? So if I delete the whole row, I will also delete 1 and headquarters and 888. But I don't want to delete that information. I need it in my database. No, you can't. You have to delete it. So sometimes if you are deleting a row and that row contains only the only information that is in the database, tough luck, you're gone. مع السلامة. So this will create a problem for you. So bad design is a lot of problems. Another design, which is, let's say, this is for delete. Let me show you also update anomaly. When you update, sometimes you'll get a problem. What about when I'm updating? For example, I want to change the manager of department number 5 from 2222 into 444, which is 444 now. What do you do? How do I update it?
You need to update it one by one.
You have to update one by one. Exactly. So you have to go to the whole table. Let's say if I have thousands of employees, I have to go to the table one by one. Each time I get 5, I have to change it to 444. Each time I get 5, I will change it to 444. Each time I get 5, to 444, and so on. So I have to do that many days. So it will take time. But by mistake, if I just do the first one, like what I did here, and I didn't do the other ones, I have a wrong information. I have inconsistency. It's confusing. Who is the manager? Is 444 the manager of department number 5 or 222? Because the database is what? Giving me 2 different informations, which is inconsistency. So that's a problem also. Well, if you have redundancy, you have to be very careful when you update. You have to have a loop to update everything. Otherwise, and it will take time. Otherwise, you will create inconsistency. So bad design is a big problem. Okay, so what do? We have to convert such a bad design into a good design. But before you do that one, let me tell you what is functional dependency, because the functional dependency is the one which will help us when you break this table into many tables, which column will go with which. Okay, Shabab? And so on. So let me explain for you what is a functional dependency. But let me take you here now. Let's assume the following. Let's say I have employees. Let me take you here first. Now I'll come back to this. Okay, sorry. I will come back to the sparrows بعدين إن شاء الله. Functional dependency. What is a functional dependency الحين؟ طبعا in the beginning it will not make sense for you what functional dependency means بالضبط يعني, but later on inshallah you will understand it when we use it يعني inshallah. A functional dependency, this is what it means. If I have two columns, let's say two columns, column A and column B. If for every value in A there is only one value in B, شفت يا شباب? Let me repeat again. These are two columns, column A and column B. Now, for every value in column A, there is only one value in column B. If this is true, then we say B is functionally dependent on A. Simply, this is what it means. Let's take two columns in a table. يعني. Let's say I have a table. It has a number of columns. Let's say this is column A of the table, and this is column B of the table. And they have values here. And also I have value here. So what I'm saying is for every distinct value of A, there is only one distinct value of B, not two. Then when we have this kind of a situation, we say B is functionally dependent on what? On A. Let me give an example. Let's say column A, these are the distinct values. Let's say, let me take it here, sorry, let me take it to this table here.
So just like if you have two unique keys?
They can be unique, they can be non-unique, okay? But let me take you, for example, let's take these two columns, department number and department name. شايفين يا شباب these two columns? Now, for each department number here, for each unique department number here, do I have the same unique department name ولا لا? Now, what are the different values here for department number? What are they? What are the department numbers يا شباب?
Department name
1, 4, and 5.
Very good. So I have this. What are the distinct values here? I have 5, 4, and 1. So let me put them here. I have 1, I have 4, and I have 5. Are you with me? So these are the department numbers. Let me just put them here. So this is one column. Let's take another column, which is department name. What are the distinct values of the department names? Let me go here. I have research, sorry. I have administration and I have headquarters. That's all. I have only 3 values. Are you with me or not? So I have headquarters. Let me just put it as H. I have research department, which I will call R. And I have what? I have
administration.
Administration. Let me put it A. Thank you. Now, each time I say 1 here, what do I say here? Do I say headquarters, or do I say research, or do I say A, or do I say combination? What do I do?
Headquarters.
So this, each time I say 1, what do I say? Each time I say 1, I am always use what? I am always matching it with what? With headquarters. Let's check. 1 headquarters. This is very easy. This is just only 1. This is only 1. 1 goes to headquarters. Does 1 go to anyone else? No. So 1 is for one we always say H هنا كان. What about each time I say 4? Do I say R, or do I say A, or do I say combination, or do I say, what do I say each time I say 4? So each time in DNA is 4, it matches which one, which D name يا شباب?
Administration.
تأكد 4A 4A 4A. Fantastic. So each 4 here will only map to one value in this. So one value of this is always mapping to only one value of this. So what it means is this is very good. So always each time 4 is matching into what? Into what? Into administration, say?
Yeah.
Very good. What about 5? Each time I say 5, each time for the DNO 5, do I have the same match here or la? Let's check. 5 research, 5 research, 5 research, 5 research. Yes, very good. So each time 5 is going to research. Oh, so because one value of this always makes one single value here, then we say the following. So we say the DNAME is functionally dependent on what? On DNO. And how do we show that? We just write an arrow. نعمل arrow between DNO and what? And DNAME. So this arrow means one value of this will always give you the same value of this, the same one value of this. At this point, clear what a functional dependence is يا شباب الحين؟ ولا لا؟
Can you repeat
So-
it?
Shall I repeat this point again? What I am saying is take two columns like D number and D name.
Okay.
Then take the distinct values in D number and the distinct values in what? In D name. So what are the distinct values in D number? 5, 4, and
1.
Very good. And what are the distinct names here? R, research, administration, and what? And headquarters.
Yes.
Then make a mapping between this and this. One always maps to what? Let's check.
Headquarter.
Whenever I say 1 here, I say headquarters here. What about whenever I say 4 here, what do I say here?
Administration.
Administration and administration. So, hey, in that case, what do we say? 4, I say administration. So always one value of this is matched with one value of this, with only one value of this. If you have this situation, we call that this attribute is, so this attribute is functionally dependent on this attribute. And how do we show it? By this arrow. DNO, make an arrow, DNAME. This means DNAME is functionally dependent on what? On D number. Let me put it for you in mathematics way. What is f of 1, ya shabab? Okay, let me tell you. This is a function. Is this a function or not? What is f of 1 here?
DNO.
H, صحيح? DNO, صحيح. But from DNO, which one?
Yeah.
H, صحيح?
Yeah.
What is f of 4?
A.
A. So what is f of what? انت تعودت على f of something, صحيح? f of 5. What is it?
It's R.
It is R. So it means this is like a function, because what does a function mean? A function means for one input you will get always the same what? The same one output, صحيح? Otherwise you are not a function, صحيح? So what I'm saying is if f of 1, for example, or if f of 4, sometimes it is what? It is A. And f of 4, sometimes it is what? It matches R. In the same, in one row I will find 4A, in another row I'll find 4R. If you find this one, this is not, معناته إيش? Automatically this is not functional dependent on this. So do you understand what a functional dependency is? معناته one value of this will always give you the same one value of that. For example, let me give you another example which is not functional dependent. Can you tell me which columns are not functional dependent? Can you tell me, Shiva? What about between address and number? Do I have functional dependency?
No.
No.
Why not?
Because 5 is with the khubar and Jubair.
Exactly, because when I say khubar here, I get 5, which is good. Khubar 5, which is good. So I'm still quick. Khubar 5, which is good. Oh, khubar 4, no. So I have a different number here. معناته إيش? Khubar is mapping to what? To 4 and sometimes to what? To 5. So in this case, this column is not functionally dependent on this column. Shall I give another example? ولا هذا واضح يا شباب?
Yes, please. Another example, please.
Another example. Let me give you another example. Let's take two columns like this. Let me create another column for you. Okay. Let's take these two columns. It's the same table. let's go back to our what they call the table that I always go to. Okay, classwork. Slides. Let's go to these tables here. Do you see these tables? Is that clear for you, Shabab? Is that clear for you? Well, not clear. It's clear.
Yes, enjoy.
Now I'm trying to find out, is there functional dependency between P and O? Let me find another one. Is there a functional dependency between dependent name and sex, ya Shabab? Or sorry, between no, not right. Let me just make a table. Let me make a table. عشان نفهمها. Let's assume I have this table here. Assume I have this table here, and I will put some values in. Oh, let me put this table. Let me use Excel. أسرع شوية. Let me create a table here. Let me put this as column. نسميها مثلا column C1, column 1. This is this. So I just want to save time. I don't want to. Sorry, معلش. I have to change this one to 18 عشان نسويها كبيرة عشان تشوفوها. This is column number 3. Okay, and this is column. Now, let me answer your question here first. Now, your question was here, يعني. I think your question was between Huber and D number. Do I have functional dependency? What I mean is the following. Each time I say Huber here, do I have to say the same number here ولا يختلف مرات? For example, Huber 5. So Huber 5. So it looks good. Huber 5. But here I have Huber 4. So here Huber is marked with 4, but here Huber is marked with what? With 5. So because of this, I cannot say that D number is functionally dependent on address. So you didn't understand me. You asked me, this is not clear. You asked me to repeat it, isn't it? One of you, the last person who asked me the question. I cannot see your name. Okay, very good. So because now a value from here is matching 2 different values from this, so automatically we say no. So the D number is not functionally dependent on address. It's not. I will learn. Okay.
Yes.
Now let's see whether the address and the manager, do they have functional dependence between the two of them, Shabab? Can you tell me?
No, because the manager can have multiple employees.
So, for example, look here. No, I'm talking about between the address and the manager here.
Yeah,
is there a functional dependency? For example, each time I say Huber here, do I get the same manager here, or sometimes I get a different manager? Let's see. Huber.
No,
Huh?
different.
Different. You have 222 and 444.
So Huber is getting mapped into 2 different what? So if I took the different managers, for example, let's take different managers. Let me just so because the time is running, I cannot make an example. So let me just take the different cities and different what? Managers. I want to find out whether manager is functionally dependent on what? On the city. So what are the different cities? I have Huber, I have Dammam, I have Jubail. See? I have 3 different cities. I have Huber, I have Jubail. Let me just put like this. I can go through it. And I have also Dammam. See?
Yes.
And what are the different managers? 222, 444, 88, 111. See?
Yes.
So I have 4 of them. See? So I have 222, 444, 888. And 111. Now each time I say Huber, do I say 222 all the time ولا مرات يختلف نشوف? So each time I say Huber, I say 222, Huber 222, which is good. Huber 222, which is good. Huber 444. So it's in fact what's happening is Huber sometimes it goes to 2 and sometimes it goes to what? 4. So when you have 2 lines emerging from here, automatically know that there is no functional dependency between the cells. So this is not true. So it means this is not true. What about this? Is it true? This way, Shabab. Is there functional dependency? This is 111, Malish. Is there functional dependency this way? Let's see. Each time I say 222, do I say Huber all the time? Let's see. 222, Huber. 222, Huber. 222, Jubail. No. So معناته ايش؟ Even 2 to 2 sometimes goes to Khuba, sometimes goes what? To Jibel. So there is no functional dependency. So there is no functional dependency between these two Shabab at all. You got the point, Shabab? So do you understand what functional dependency is now? Wala la?
Yes.
Simply take the distinct values of one column and the distinct values of the other column if you want to know if there is functional dependency between them, and then do the mapping. If from one value here you are drawing two lines, or it is going to two different values here, automatically there is no functional dependency. It's not a function anymore. Okay, Shabab, is that clear? Let me stop here and I will continue the next class. How do we use this one to break a bad table like this into a good table like this? I'll talk about this one in the next class. So the next class, I will show you this, what I just showed you, these functional dependencies. It will help me to break the table into many tables. And I will show you that one in my next class, inshallah. Any question?
No, thank you, Doctor.
Yes. Okay, no question, Ashok? Any question, please? If you have any question, ask. Let me just take attendance. I don't want to forget. Any question? So you got it? It is easy, inshallah, up to this point, hopefully, okay? Okay, so I did email you about, I don't have office hours today because I will be busy with something else. So I will keep tomorrow the same time, the office hours. So I will just move for today's office hours into tomorrow, only for 1 week. Okay, Shabab? So if you have any questions, please come tomorrow. Okay. Okay, thank you very much. And okay, I'll see you, inshallah. Assalamu alaikum.
Thank you, Doctor.
Okay. Yeah. Hopefully we'll see you soon. Yeah. I don't know, because did you hear that we got vaccine al-hin?
Yes.
Yes,
Yeah,
soon.
but it will take some time until it reaches us. Eh? Yeah.
Inshallah, second semester.
Inshallah.
Do you think, Doctor, the finals will be in the college and the university?
Oh no, for the undergraduate it will still be online, because this vaccine, first of all, I think it will come in December into the US, yani.
Yes.
Until it comes to here to Saudi Arabia, maybe another, I don't know, few months come on, yani. So I'm not sure even next semester will be what will be, yani, most probably it might be online and for some time, yani. This is what I think, yani. I'm not sure. I haven't heard anything, but my feeling is even next semester, some part of next semester will still be online, most probably, unless this vaccine comes very quickly to us. Okay.
The next semester will be probably online.
Most probably, لو ما عندنا vaccine, most probably it will be online, صحيح? Most probably. I'm not sure, but this is what I feel, يعني. Okay, but we will hear from the Minister of Education. They will tell us exactly